Good morning, viewers. I am Saraswati from CST department. I have to talk about some of the heuristic search algorithms in AI. A heuristic search is nothing but a heuristic technique that employ a heuristic for its move. A heuristic is a rule of thumb that probably leads to a solution. It's a major role in search strategies because of the exponential nature of the most problem. It reduces the number of alternatives from an exponential number to a polynomial number. There are different varieties of heuristic search algorithm: generate and test, hill climbing, best search, A star and AO star, problem reduction, constraint satisfaction, and means end analysis. Let us see one by one. Generate and test. The generate and test search is a heuristic search technique. It is based on the DFS algorithm with backtracking, which guarantees to find a solution if done systematically, and there exists a solution. It generates all the possible solution and tested for the best solution. To ensure that best solution is checked against all the possible generated solution. It is also known as a British Museum search algorithm. It's like looking for an exhibit at random or finding an object in the British Museum. The evaluation is carried out by the heuristic function as all the solutions are generated systematically in generate and test algorithm. This is a algorithm. First, we have to generate a possible set of solutions. For example, generating a particular point in the problem space or generating a path for a short state. Test to see if there is an actual solution by comparing the chosen point or end point. If a solution is found, quit. Otherwise, go to step 1. This is a diagrammatic representation of the generate and test method. Generator generate a possible set of solutions. Tester check the solution if it is correct or not. If the correct solution is found means stop the process. Otherwise, repeat the another possible set of solutions. Next one is a hill climbing algorithm. Hill climbing algorithm is a local search algorithm which continuously moves in the direction of increasing value to find the peak value of the mountain or to find the best solution of the problem. It terminates when it reaches the peak value, that is, no neighborhood has a higher value, which is used for optimizing the mathematical problems. The hill climbing algorithm is used in traveling salesman problem. It's also called as a greedy level search algorithm. Hill climbing algorithm is a good heuristic search algorithm. There are some features of a heuristic method: generate and test variant, greedy approach, no backtracking. It does not have a backtracking. Greedy search, it's perform the search moves in the direction which optimize the cost. Generate and test variant. The variant of generate and test will produce the feedback according to the possible set of solution, which helps to decide which direction to move in the search space. This is a state space diagram. In the diagram, there is x-axis and y-axis is there. The diagram represents the objective function versus state space. In x-axis is a objective function means we can calculate the global maxima and then local maximum value. In y-axis is a state space and x-axis is a objective function means we can calculate the local maxima and local minimum value. These are the different regions in the state space diagram: local maxima, global maxima, current state, flat local maximum value, and shoulder. Local maximum is which is better than its neighbor state. Global maxima, it's a possible set of state space landscape. There is a highest value of a objective function. Current state is where the agent is currently present. Flat value, in that all the neighboring states of current state have the same value. Shoulder, it's a plateau region which has an uphill edge. There are 3 different types of hill climbing algorithm. First one is a simple method. Second one is a steepest ascent hill climbing. Third one is a stochastic hill climbing. Simple hill climbing is it only evaluates the neighbor node state at a time. and select the first node which optimize the current cost and set it as a current state. If any one of the success state check and if it finds better than the current state, then move it to the same state. Steepest ascent. Evaluate the initial state. If it is goal statement, then return success and stop. Otherwise, choose the next initial state. Second step. Loop until a solution is found or the current state does not change. The successor be a state, that is, any successor of the current state will be better than it. For each operator that can apply to the current state, apply the new operator and generate a state. The operator, it may be a add, delete, move, etc. And evaluate the new state. If it is a goal statement, return the state and quit the process. Compare it the successor. If it is better, mean set the new state as a successor. If the successor state is better than the current state, then set the current state to the successor. Stop the process. This is a steepest ascent hill climbing algorithm. Stochastic. It does not examine for all its neighbor before moving the nodes. Rather, this search algorithm select one neighbor node at random and decide whether it chooses to see current state or whether it is examine another state. This is a stochastic hill climbing algorithm. That's all. Thank you.